Now we're going to talk about compound inequalities. There are two types of compound inequalities that we are going to focus on, and those are and or. An and inequality might be something like, I can go to the gym between 5 and 7. So that means I could be at the gym anywhere from 5 to 7. This is my time space that I could be at the gym for. Somewhere between 5 and 7. An or inequality might say, the movie is showing before 2 or after 5. So here's 2. I know the movie might be somewhere before 2 or it might be somewhere after 5, but it's not in between 2 or 5. It's either before 2 or after 5. Now let's look a little closer at this and inequality. The compound inequality containing the word and is true if and only if both inequalities are true. So in this example, I'm telling you that x is greater than or equal to -4, and I'm telling you that x is less than 3. So I've plotted greater than or equal to -4, and we've plotted less than 3, and we can see that there's an overlap between where those two things are happening. That makes it an and inequality. Both things are happening at the same time. Let's look at an example of solving for an and inequality. We've got 8, which is less than 3y minus 7, which is less than or equal to 23. When we have inequalities on both sides, we're going to do our reverse Pemdas as if we were solving for a regular inequation or inequality, but we're going to do it to every single part of this inequality. The left side, the middle, and the right side. So first we're going to add or subtract, so we can add 7 to every single piece in this inequality. 8 plus 7 is 15, which is less than -7 plus 7 is 0, so we're left with 3y in the middle, and that's less than or equal to 23 plus 7 is 30. Then we're going to divide every single piece by 3. 15 divided by 3 is 5, which is less than y, which is less than or equal to 10. So now this is our simplified inequality. Before we do this in interval notation, first I want to look at the graph just to get a visual of what this looks like. So this is saying we want every single y value that is between 5 and 10, but it can include 10. I don't want to include 5. I can include 5.1, but I can't include 5. I can include 10, but I can't include anything bigger than that, like 10.1. So when we're graphing this, remember if it's strictly less than or strictly greater than, we're going to put our open circle. So at 5 here we have our open circle. If it's less than or equal to or greater than or equal to, that's when we have our closed circle. That'll be at 10. So we have this closed circle at 10. And this is saying that y is in between those two values. So that means between our two circles that we just drew, that's where our graph is. Every single thing that's between 5 and 10, but it includes 10. That closed circle is saying we're including 10 in our answer, but we're not including 5, so we're leaving a hole there. Now when we're doing interval notation, if you have a circle on your graph, or if you're using strictly less than or strictly greater than, we're going to use parentheses with that number. So since we are using a circle at 5, we're going to put a parentheses with the 5. And then this interval is saying we're going from 5 to 10, so the lowest that we were at was 5, the highest we can get to is 10, so next I'm going to put a 10, because that's our highest number in this section of the graph. And then since it's a closed or filled in circle, or since we're using the less than or equal to sign, then we can use a bracket. So this is the interval from 5 to 10, that's where our y value lives. A compound inequality containing or is true if one or more of the inequalities is true. So here we've got x greater than or equal to 5. So from 5 we are increasing. Then x less than -3. So now we're decreasing from -3. Notice here there's no overlap. We have arrows going in opposite directions, so there are two different answers here. We could have an x value that's bigger than 5 or equal to it, or we could have an x value that's less than -3, but nowhere in between. So here we've got k plus 6 is less than -4, or 3k is greater than or equal to 15. So in both of these inequalities, we're going to solve for k. On the left side, we need to subtract 6 from both sides. So now we have k less than -10. On the right side, we need to divide by 3. So now we have k greater than or equal to 5. So again, I'm going to graph it first. So at negative 10, I have an open circle because it's strictly less than. And k is smaller than this negative 10, so we are decreasing. So we're going to the left. Then we have k greater than or equal to 5. The tick marks aren't exactly at 5, so I'm going to put it somewhere in between 4 and 6. It was greater than or equal to, so we have that filled in circle, and k is bigger than that number or equal to it, so we're going to increase, we're going to go to the right. Now, if we have arrows pointing in opposite directions, we're going to have infinity in our interval. So starting with this left side, since this arrow is going to the left forever and ever and ever and ever, it's getting really, really, really close to a giant negative number that we're going to call negative infinity. Now with negative infinity or with positive infinity, we are always going to use parentheses. So we're starting with negative infinity. Then from the left, as we get bigger, we're getting to negative 10. And again, there's an open circle. So I'm going to put my negative 10. And we have parentheses because of the open circle. Then we make this jump all the way from negative 10 to 5. We're not including any of these numbers between negative 10 and 5. So we're going to put a U now. U stands for union. It is the union of this interval and the next interval that we're going to write. So the next interval, the lowest that it gets, starts at 5. This time we have that closed circle, so we're going to use a bracket. And we started at 5. And then since it's going to the right forever and ever and ever, and it's never going to stop, this one's going to positive infinity. And again, our infinities have parentheses. So that is the interval notation of this example.